Hi everyone, this is the Radical Tutor here explaining. In today's video, we'll be looking at RS naming systems. So we'll be looking at RS naming systems, and now we need to understand what these RS naming systems are. So RS naming systems are actually basic rules that are used in the naming of enantiomers and diastromers. So we use the RS configurations to name the enantiomers or diastromers. So mostly we target a molecule or molecules that have a chiral center. So we go for those molecules that are chirality in nature. All right. So by chirality in nature, I mean molecules that have, four different atoms attached to a central carbon. So in this case, as you can see, for the first question, we have four different atoms attached to this atom on the middle here. So to this atom on the middle there. So meaning that this molecule is a chiral molecule because it has four different atoms attached to it. All right. So now how then do we name or assign the RS configurations to these type of molecules? So what we do is to start giving them numbers or to assign numbers in descending order, starting with the one that has the greatest atomic mass. So that's what we do. So I'm saying you assign numbers starting with the one that has the greatest atomic mass. So that one is the atom or element that becomes the most precedent in your assigning. So what you do is you start assigning. So let's say, for instance, between or among these elements, which one has the greatest mass number? So you are going to find that bromine has the greatest mass number. So for instance, bromine will be given number 1. So we are going to assign number 1 to bromine, and then we go to the other one that follows in terms of the atomic mass is chlorine. So chlorine will be given number 2. Then from there we have this group which is coming here. Hope you're able to see this group here. That is an ethyl. So an ethyl will be assigned number 3 because that is carbon. There is a carbon here. So number 1 is bromine, 2 is chlorine, 3 is carbon, and then number 4 is the hydrogen because hydrogen, you know that it has an atomic mass of 1. So from there then, what you need to do is to show the direction in which you are moving. So if we are to show the direction, you are going to find that the molecule will move like this. Okay, that's how it is moving. Number 1, number 2, number 3, number 4. So it's moving in that direction. So now what happens is that if a molecule is moving, if the direction that you are taking is clockwise, meaning that that becomes an if it's clockwise, so if you do like this is clockwise and then this is anti-clockwise. So if it is going clockwise, then it becomes an R, and then when it goes anti-clockwise, then it becomes what? An S. So in this case, you check which direction have we taken in our molecule. So you are going to realize that the direction taken there is anti-clockwise. This molecule is moving anti-clockwise like this. So it is moving in the anti-clockwise direction, meaning that it becomes what? It becomes an S. So you say this is what? This is S configuration. All right. So you say it is an S. It is an S because it is moving anti-clockwise in the anti-clockwise direction. All right. So now from here we go to this other one which is down here. So the one which is down, we again assign the numbers in descending order according to their atomic masses. All right. So you start here. You are going to find that first thing first is to determine the chiral center, that atom which is bounded by 4 different atoms. So in this case, you are going to find that your chiral center is this one here because it is surrounded by this, which are 4 different atoms attached to it. So this becomes our chiral center. So now after you've identified that that is your chiral center, what you then need to do is to say this oxygen which is attached to the central carbon is our number 1. And then we go to which one comes next. So when you look at all these elements or atoms which are attached to this chiral center, you are going to realize that they are all carbons. So if they are all carbons, meaning that there is a tie among those elements because they are all carbons. So what then do we follow if there is a tie? You need to check if there is any carbon which is having a double bond, then that should follow, or that should be the one given the highest precedence in the assigning system. So meaning that this is going to be our number 2 because of the double bond attached to it. Then again you follow, there is this carbon and this carbon, which one is going to be number 3? So this carbon is going to be number 3 because it is attached to this other longer group which is following there. But when you look at this one is only attached to 3 hydrogens. So meaning that this is going to be our final carbon. Okay, so we call it as the lowest group in that case. So now after that you need to take the direction. So taking the direction is, this is number 1, number 2, number 3, number 4. So meaning that your direction is going to move like this. Alright, so this is still what? This is still an S because that is anti-clockwise. So this is an S. So you say it is an S configuration. Alright, so this is how you're supposed to assign the RS configurations to any given molecules. So you can do this as your task. Please feel free to do the task and then send it in my inbox for confirmation so that I can affirm and see if at all you've done the right thing. Please don't forget to like my page, follow, and subscribe to my channels across all social media platforms.